So like I said, today we're going to be talking about what happens when we get groups of atoms together. What are the different ways that we can combine and mix our atoms, our particles, and turn them into something different. So that is what we're going to be getting into tonight. The different ways that we can classify matter. All right. So I'm going to start off showing you guys kind of this big flow chart of everything that we're going to talk about for tonight. And then I'll go through each piece kind of little by little, break it down for the different stuff. And then we'll come back together at the end and see how it all works together to be sorted into kind of these different categories. So here's kind of everything that we're going to be talking about tonight. We're going to see if our matter is one single pure substance or a mixture and combination of different things. And then we're going to see what sort of particles is our matter made up of. And if it's mixed together, what type of mixture do we have? Do we have an pure, even, equal mixture, or do we have an uneven, chunky, unequal type of mixture? So don't worry if nothing on this flowchart makes sense to you right now. Hopefully it should all mean something by the end of class tonight. So remember, matter is just our fancy science word for stuff. So everything in the universe is matter, and we can sort of classify it into these different groups. So the first type of matter that we are going to talk about tonight is called pure substances. And a pure substance is exactly what you think it is. It is when there's only one type of particle present in a substance. So only one atom or only one molecule is present in our substance. We have 100% pure matter of whatever type of thing that we're talking about, whether it's carbon or water or ethanol or whatever it is. A pure substance means that particle is the only particle that is in our matter. Nothing else is mixed in or combined with it. So there's kind of two different types, two different flavors that our pure substances can come in. There are elements, which are like single atoms, and there are compounds. So for tonight and on your homework, you'll see these guys represented as just kind of these basic dots. So a single atom, a single element is just one type of dot. And then compounds, as we'll talk about in a little bit, are when we have multiple atoms that are all connected together. So pure substance, we could have a pure substance made up of elements, meaning only one single type of atom is present. Or we could have a pure compound where only that one single type of compound is present. Again, each compound, and we'll talk about compounds more in a second, but each one counts as one particle, one single type of molecule or particle. So that's why I say one type of particle and not one type of atom. Because you might have different atoms, but as long as they're all bonded together in the exact same way, it is still a pure substance. So if every single piece in our picture or in our matter looks the exact same, it's a pure substance. So elements are obviously the most simple kind of versions to look at. Elements is basically just another fancy way of saying atoms. So when we have a pure substance made out of elements, that means that matter is composed of identical atoms. Every single atom in this piece of matter is the exact same. So like this copper vase right here, every single atom in this vase is copper. There's no like oxygen or carbon or iron or sulfur mixed in. If you were to look down at the microscopic atom level, every single atom that you could see in this vase is a copper atom. Same thing with these gold bars right here, right? So in these gold bars, every single atom is a gold atom. Remember, gold is one of those weird ones where it has a different symbol than what you'd think based on the name. So the symbol for gold is not G or GO, it's AU. Don't ask why, it has to do with old-timey naming stuff. But if you look microscopically at these gold bars, it would be 100% gold. There's no like other metals like nickel or tin or lead or anything mixed in. It is 100% complete pure gold. So every single atom in this substance is the exact same. It is a pure substance made out of only one type of element. So no other elements, no other atoms are mixed in. It's all the exact same atom over and over and over and over and over again. So elements are when we have one single type of atoms. But what happens if we stick a couple different atoms together? In that case, we get something called a compound. So a compound is when you have two or more different elements that are bonded together. So like in that picture we were just looking at a little bit ago, you have the white element and you have the black element. And in this case, you have one black atom that's bonded to two white atoms. So this is a single compound right here. All of these guys are different. Well, they're not all different, but they're different, right? There's at least two different atoms here, black and white. And they're all bonded together. They're making up one larger particle, one larger compound. So when things bond together and make compounds, you end up with different properties than the individual elements. They have to, in order to make a compound, you have to go through some sort of chemical change. So remember when, like back on the first week or second week of class, we talked about the chemical changes versus physical changes. And I said physical is when you take something and you change how it looks, but it's still the same substance. Chemical is when you take one substance or one set of substances and turn it into something new. That's what happens when you make a compound. You take a couple different atoms and form them together to make a new substance, which is called a compound. So salt is a pretty common compound. Salt is when you take sodium atoms, Na, and chlorine atoms. Separately, these guys are very reactive and very dangerous, actually. Pure sodium will explode if it comes into contact with water. And pure chlorine is a gas which is very poisonous to breathe. But you put them together, and all of a sudden you have a totally new substance, a totally new compound, NaCl, aka sodium chloride or salt. So two different atoms that are bonded together. That is what makes a compound. Other common compounds that you may be familiar with without even realizing it include things like water. So the chemical symbol for water is H2O, which you've probably heard before. But what that stands for is 1 oxygen and 2 hydrogen atoms that are bonded together. So if this is a totally pure 100% water substance, then that would mean every single particle in here is H2O. No other sorts of particles or particulates or anything floating around here. It's all 100% completely pure H2O compounds. That's what would make it a pure substance, if there's only H2O in this glass of water. Another common compound is carbon dioxide. So CO2, or carbon dioxide, the stuff that we breathe out when we breathe, or that comes out of the tailpipe of your car or these smokestacks of factories, is 1 carbon and 2 oxygen atoms that are bonded together. So CO2, again, different atoms that are bonded to each other. They're stuck together, just like we saw in that earlier picture. Ethanol is another very popular compound. So C2H5OH, this is the type of alcohol that goes into the things that we drink. So when most people think of alcohol, they're really thinking of ethanol. And so there's lots of different alcohols that are out there, but ethanol is the one, and beer and wine and spirits, stuff like that. And so these are, obviously now we have 3 different atoms, C, H, and O, but they're all still bonded together. And so if you had something that was 100% pure ethanol, like something you'd use to like clean wounds or something like that, that means that this is the only particle that is in that bottle. It is only C2H5OH that is in there. No other compounds or atoms are floating around. There's no other like loose carbons or loose nitrogens or loose hydrogens or something floating around in there. It's all 100% pure ethanol. All right, so we have our elements, which are single atoms on their own, making percent pure substance. And we have our compounds right here. So again, compounds, 2 or more different atoms. So you could have 2, or you could have 3, like these guys, or you could have 9, like these guys. But as long as they're all bonded together, that makes 1 compound.
What is H5?
So that stands for 5 hydrogens. So ethanol is a compound made out of 2 carbons with 5 hydrogens on them, and then there is an OH group on the end. So there's an oxygen and a hydrogen attached at kind of the end of the little chain. So the numbers down here just represent how many of that particular atom are in the substance. So like water is 2 hydrogens and an oxygen. Carbon dioxide is 1 carbon and 2 oxygens. So those are our compounds, different atoms that are bonded together. They're stuck together. They're linked to each other. And again, if that's the only thing in our substance, if you look at our matter and it is only 1 single type of compound, then you still have a pure substance. You still have something where it's only that 1 type of particle that's there. Even though they're not all the same atom, as long as they're bonded together to make 1 compound, and that's the only thing that there is, that still makes it a pure substance. All right, so before we move on, does anybody have any questions about elements, compounds, or pure substances? Anything that you're still a little confused on or a little not sure about? All righty. So we've been talking about pure substances so far, which is where we only have one single type of particle there. Maybe it's one element on its own. Maybe it's one compound made up of a couple elements together, but that's the only thing that's there. But what if we have a combination of different elements and different compounds all combined, all swirling around together? In that case, we no longer have a pure substance, but we have what scientists call a mixture. So a mixture is when we have some sort of combination of two or more pure substances. So we take two different things that are pure on their own, but we mix them together. So we end up with multiple different particles all mixed together. So in this case, we got this little black atom right here, and this double white atom right here, and this black and white particle right here, all swirled around all together. So obviously we don't only have one type of particle anymore. We have one, like this guy, and this guy, this guy. We have two, like this guy, this guy, this guy. And we have three, like this guy, and this guy. So now we have multiple different particles all combined together, all swirling around each other. And that's what gives us our mixture. So when you no longer have just one single type of particle, but instead multiple types, that is when you go from being a pure substance to being a mixture. So let's look at our different particles in here. Like I said, we have three different ones. And so I'll go through them one by one, and I want you guys to tell me, is it a element or is it a compound? So we'll start easy. This black dot atom right here, is it a single element or is it a compound?
Element.
Compound.
So these guys are elements. So these dots, this is just one single atom. And so when there's just the one single atom, we call that an element. What about this guy right here? The one black and two white elements stuck together. Are these guys elements or compounds?
Compound.
Compounds. Bingo. Good answer. But yeah, we have the one black and two white. They're stuck together. So we have multiple different elements together, and that's what makes a compound. So now I have a little bit of a tricky question for you. What about these guys right here, these double white atoms together? Are these guys elements or compounds?
Elements.
Ooh, excellent answer. Elements is correct. Because, as I'm sure you noticed, these guys are the same atom. You got a white atom and a white atom together. And compounds, if you recall, need to be different elements. So sometimes, just because of their reactivity levels, certain atoms really like to join up with their twins. So like in nature, you'll almost never see a hydrogen atom floating around by itself. It's almost always combined with another hydrogen to make H2. Same with oxygen. The oxygen that we breathe, you've probably heard it referred to as O2 before. And that's because oxygen is very rarely floating around as just a single oxygen atom. It really likes to join up with a second oxygen atom to make O2. But those guys are still elements. They're still the same atom. There's just two of them together. In order to make a compound, we need two or more different elements. So because these guys are the same element, it is not a compound. It's still just one element. In this case, it's the one white atom element. Only this guy is a compound because this guy is different atoms, different elements together. White atom and black atom together. That's what makes this a compound and not an element. So when you have different elements together, or when you have different compounds together, or when you have different elements and compounds together, that's what makes a mixture. We no longer have just the same compound or element repeated over and over again. We have lots of different types of compounds and elements. So, not all mixtures come in the same flavor, as it were. We can take our kind of general idea of a mixture, look at how the atoms and compounds and whatnot are arranged in there, and sort mixtures into two different groups. So our first group of mixtures is called a homogeneous mixture. Homo in Latin and in science in general means one or one type. And so homogeneous means one type of mixture, or similar, like same, sorry. Homo doesn't necessarily mean one, it means like same or similar. So homogeneous mixture means everything is the same in the mixture. We have different particles, but their distribution is all equal and even. So all the different parts of your mixture have the exact same combination of atoms and compounds. So sometimes we also call it a solution. So no matter where you go in your mixture, no matter what part of it you look at, it should all look the exact same. All of the elements and compounds are totally equally and evenly mixed and distributed. There's not any more of one type in one section and then a lot less of another type in another section, and then there's almost nothing over here. They're all totally evenly spread out and equally distributed. In general, this happens when you have very small particles, so things that have really big, chunky particles can't do this as well. It helps to have them small. Hey, Vanessa, good to see you. And the particles are always kind of floating around each other. They never settle, meaning that they never like fall down to the bottom of your glass, like if you have too much sugar in your iced tea or something like that, or you get coffee grounds in your coffee. In a mixture, the particles are always totally suspended around each other. So something like eye drops is a great example of a homogeneous mixture. Every single drop out of the little dropper bottle should have the exact same combination of like medicine and saline when it goes in your eye, right? You don't want the first couple drops to be like super watery and the last couple drops to be like super concentrated, and they just sting really bad when they get in there, right? Every single droplet out of this from the start to the end has the exact same combination of saline and water and medicine, because that is all evenly distributed. There's no more of any type of medicine in one area of the bottle versus the other area. You don't have to mix it up before you put it in your eye. It's all totally evenly spread out. Some other kind of household homogeneous mixtures that I think make good examples. Something like mouthwash, right? So when you put the mouthwash in your mouth and swirl it around, which young boy Michael did not realize that's what you're supposed to do with it. So I think the very first time I ever had mouthwash, I poured some into the little cap and then put it in my mouth and swirl it around and then swallowed it. And my mom was like, "Whoa, why'd you do that?" And I was like, "Well, it's mouthwash, you're supposed to." And they were like, no, you swirl it and then you spit it out. And I was like, oh, that makes more sense. So you swirl it around in your mouth, and every single bit of this mouthwash tastes and feels the exact same. It should have the exact same combination of like the disinfectant and alcohol, if it's that kind, and antiseptic stuff that's supposed to kill all the germs in there. But from the start of the bottle to the very end, all of the particles are totally evenly distributed. Same thing with something like vinegar. So the acidity of vinegar comes from a compound called acetic acid. That's what makes vinegar vinegar. And so bottled vinegar is a mixture of acetic acid and water. And it is a homogeneous mixture. Every capful of vinegar from the start to the end is the exact same. No matter where you go in this bottle, it's the exact same combination of vinegar and water, or the acetic acid and water. Coffee is another really good example of this. So specifically, if you have like a pour over coffee or a traditional drip coffee maker, the filter up at the top holds on to all the coffee grounds and stuff like that. And then the mixture of the water and caffeine and coffee flavoring and all the different compounds that are in coffee that you want to drink in the morning, even though coffee tastes gross and is nasty, all of that stuff all gets evenly mixed throughout the coffee, right? Ideally, especially if you don't put any like sugar or milk in it, every sip of coffee should taste pretty similar from the start to end. They all have an equal and even homogeneous mixture of water, coffee, caffeine, and all that good stuff. One of my personal favorite examples of a household homogeneous mixture is smooth peanut butter. I personally am a huge fan of peanut butter. I think it's great. I still eat peanut butter and jelly sandwiches on a regular basis for lunch. They are delicious. But smooth peanut butter is a mixture of ground peanuts and oil and usually a little bit of sugar. And so in a totally homogeneous mixture of peanut butter, every scoop should taste the same. Should have that same combination of ingredients. You shouldn't get to the bottom and there it gets like super oily and nasty down there. Sometimes that happens if you ever buy like the 100% natural peanut butter or the peanut butter that you like make yourself from the powder. When you do that, sometimes the oil kind of collects on the top, and then when you open it again, you have to like stir it around to mix the oil in. In that case, when the oil rises to the top, that creates not a homogeneous mixture because you have all the oil up here and the rest of the peanut butter mixture down here. It's not evenly and equally mixed. Same thing with if you get chunky peanut butter, right? I do like me some chunky peanut butter from time to time just to kind of mix it up a little bit. But chunky peanut butter, as we all know, has those big chunks of peanuts distributed throughout. And those are kind of close to evenly distributed, but they're not 100% equal. Each scoop of chunky peanut butter might have slightly different amounts of peanuts versus peanut butter in it. So that would also make it not a homogeneous mixture because not every single piece, not every single scoop is going to be the exact same. So homogeneous mixtures, homogeneous, everything is equal and even, the same throughout the entire mixture. So like in a coffee example, I don't know if you guys have ever used a French press coffee maker before. My wife is a big coffee person. She has 17 different contraptions at home that make coffee in different ways. One of them that she uses sometimes is a French press, which is where you mix the beans, the ground up beans and the water, hot water directly in this little coffee container. Let it sit for a little bit, and then you take a little plunger and you push all of the grounds down to the bottom so that it holds them there while you drink the coffee from the top. So that is obviously not a homogeneous mixture because you have all the coffee grounds that are squished up and crunched down at the bottom, and then the liquid coffee is floating around the top. So all the stuff in our mixture is not even and equal. We have this difference between the bottom and the top. So that is not a homogeneous mixture because homogeneous is equal and even. Everything is totally spread out the exact same way no matter where you go in the mixture. So if we don't have a homogeneous mixture, if we have some coffee grounds in our coffee, or we have some peanut chunks in our peanut butter, then we have what is called a heterogeneous mixture. So hetero in science and Latin means different, So heterogeneous mixtures are when we have different combinations of particles. We have an uneven, an unequal distribution of all of our different parts. There might be some more of one type of particle over here and more of a different type over here, but there's less of those two, more of a third one down here. That makes it uneven. It's not all totally evenly the same. So some areas might have particles that are really clumped together. Other areas might have those same particles, but they're more unequally spaced out. So like this granite, for example, if I took a little bit out of the granite right here, like I took a little square out and compared it to the other squares, none of them would be the exact same, right? If you look at it from far away, it looks like it's all kind of the same mixture of grays and whites and blacks. But it's not 100% the same no matter where you go. Like if I look really close, right here is a little bit more white, and over here is black, and right here is kind of a dark grayish section. That has to do with all of the different minerals and stuff that make up the granite, all kind of get clumped and packed together differently, which is what gives it all these different colors. So because no matter where you go in this granite, it's all different pieces set up in a little bit different way, that makes it a heterogeneous mixture. Some areas have more of this mineral, some areas have more of another mineral, some areas have not very much of either of those minerals. It's not all even and equal. We have unevenly distributed our particles. So other kind of everyday heterogeneous mixtures, something like a salad, for example, is a good example of a heterogeneous mixture. Every bite out of this salad picture here could be a little bit different. Some bites might have some more spinach on them. Some bites might have more strawberries and blueberries. Some might have some more of this cheese with the, I can even tell, maybe pineapple or something. If you put on some salad dressing, some areas might have thicker salad dressing and some have thinner salad dressing. Over here and over here, I see some almond slivers, but I don't see any almonds over here. Everything is mixed together pretty well, but it's not completely evenly mixed. If we wanted to do that, we'd have to put it into some like super hardcore blender and blend it all up into some kind of nasty green colored drink that is not very fun to drink / eat. So if you eat it as a salad, you get different clumps of different stuff in different areas, and that makes it heterogeneous. Same thing with if we put this zesty Italian dressing on it. You can see the dressing itself is made out of a combination of water and oil, but then you see all these little chunks of, I think it's like garlic and pepper and maybe other stuff in there too. And no matter where you go, there's a little bit different combination of chunks. Over here, there's a little bit more of the pepper. Down here, there's a lot of garlic, but then there's some more pepper here. But then up here, there's not very much of either of them. They've kind of started to settle out to the bottom. So no matter where you go, it's a different combination. We don't have the exact 100% evenly distributed parts. Same thing, even if you just look at the soil underneath you. If you go and pick up a clump of dirt from the ground, that dirt might have some soil, but also some sticks, but also some rocks, and there could be some bugs or some worms moving around in there. So it's a completely random mix of stuff that all goes into what we just kind of call dirt or soil. You can even see there's different levels in the soil based on what types of minerals and compounds are in there. So we have this darker soil up here, which is a different mixture of stuff compared to this orangey soil right here, which is a different mixture of stuff compared to this lighter gray soil down here. And all throughout, we have this different combination of rocks and plant roots and sticks and stuff all buried down here. So a completely random, unequal, uneven distribution of all the different parts that make up the soil together. So heterogeneous is all about not being equal and even, having different amounts of our particles spread to different areas of our mixture. All right, so homogeneous, all totally evenly and equally spread out and the same. Heterogeneous, lots of different areas, not all totally the same. They're both mixtures. They both have a combination of compounds and elements all mixed together, but how they are mixed determines what type of mixture that you have. All right, anybody have any mixture questions, homogeneous, heterogeneous questions, anything that you're still a little bit confused about or not sure on?
No.
All right, let me get some more water here real quick. So if we put it all together, we have our two different groups of matter. So separated by physical means just means could we go in and pull out the different types of particles that are in there? If it's yes, that's because it's a mixture. So in a mixture, we have lots of different types of particles that are in there, different compounds, different atoms, all mixed together. If we can't, if there's only one type of particle present, we have our pure substance. Nothing is different. All the particles are the exact same. So in our mixture, if we have uniform composition, meaning everything in our mixture is totally even and equal, that's when we have a homogeneous mixture. All the different parts of the mixture, no matter where you go, are mixed together basically the exact same way. If it's not uniform, if we have random groupings and random amounts of particles in different places, then we have a heterogeneous mixture. Different amounts, not the same. It looks different depending on where you go. On the other hand, if we have a pure substance, we could have a pure substance made out of different atoms that are bonded together, which is a compound. However, if there's no different atoms, if every single atom in our substance is exactly the same as all the other atoms, then that's when it is just purely that one single element, that one single type of atom. So homogeneous and heterogeneous mixtures are combinations of different compounds and elements. So these guys are still made out of these guys. It's just that if we only have one type of particle on its own, we have a pure substance, whether that is one single type of compound like water or carbon dioxide. So again, different atoms, but they're fused together and every single particle looks the same as all the other ones. Or maybe we just have the one single pure type of atom, in which case it is just an element that is in there. So one atom on its own or an atom that's bonded to itself is elements. Different atoms that are bonded together make compounds. All right, does anybody have, now that we've kind of put it all together and looked at all the different pieces, does anybody have any questions on mixtures versus pure substances? What makes a compound versus an element versus the different types of mixtures? Any questions from the notes so far this evening? Anything that you're still a little confused on?
No.
Okay. So the reason why I wanted to hit home the differences between those different types of substances is that your homework for today and tomorrow will have to do with trying to identify different types of mixtures or compounds or elements or pure substances. So for example, for each one of the homeworks, they're set up in the same way. I think today's has 2 different substances. Yeah. And tomorrow's has 3 different substances. But for today's, there's a little section set up here at the beginning as kind of a review of the stuff that we've been going over. So we have our single individual atoms right here. They can be on their own or they can be fused together, but these are still elements. If we take different elements and bond them together, we have a compound, but as long as that's the only compound or that's the only element that's there, it's still a pure substance. And then finally, if we take different compounds and elements and mix them all together in a new substance, it is called a mixture. So we could have homogeneous mixtures, which is where everything is the same amount mixed together in the same way, evenly and equally distributed. So if you look at our homogeneous mixture example right here, you can see that no matter where we go, we have about the same combination of black and white compounds, black elements, and white elements. So it might not be perfect, but there's not really any areas where there's a lot more of one type of element versus another. They're not grouped up together anymore in one area versus another. No matter where you go, you can find a pretty good mixture of compound black and white element. Versus our heterogeneous mixture over here, where you have all of the black elements clustered here on the left side, and all of the white elements are clustered here on the right side, and all of the compound is clumped together in the middle. So obviously this is very unevenly distributed. There's no black elements over here, there's no white elements over here, and there's none of either in the middle. So we have a heterogeneous mixture. So for each substance that I'm going to show you guys a picture of for today's homework and tomorrow's assignment, I want you to tell me 2 things. First off, what type of substance is pictured? Is it a pure substance? Is it a heterogeneous or homogeneous mixture? And then second, on each substance, I want you to tell me what type of particles are present. Are there only elements that are present? Are there only compounds that are present? Or are both elements and compounds present in that substance? So today you have this white dot substance and this white dot and white and black dot substance down here. Again, pure, heterogeneous, or homogeneous mixture. And are there compounds, elements, or both in there? And then tomorrow's assignment will be very, very similar with 3 new substances. So this is what is going up for your daily Wednesday assignment. We have this black and white dot substance. We have this black and white compound substance. And we have this 1 black and 2 white particle substance. So that is what your daily assignments look like for tonight and for tomorrow. Just for each one of those substances, tell me what type of substance is it versus in terms of pure substance versus one of the mixtures, and what particles are present. Are there elements that are there? Are there compounds that are there? Or are both of them there mixed together? All right. Does anybody have any questions about the homework, the daily assignments for today or for Wednesday, tomorrow?
No, sir. No.
Cool. Cool. All right, so the one last thing that I wanted to show you guys for tonight, I saved the important one for last here, and that is we are at just about the halfway mark of the term. We are in week 4 out of 8 as we speak. And so because we are halfway through the term, that is time to get to our first midterm exam. So the midterm exam is a large exam test style assignment that I have you guys do once halfway through the year, and then we'll do another one, the final, at the end of the term. The midterm is set up a little bit differently from your normal daily assignments, that it's not a one-day only assignment. It'll be posted tomorrow morning, but just like the title says, it is not due until Friday. So April 30th, which is Friday, at the end of the day, that is how long you have to work on the midterm. So you have all day on Wednesday, all day on Thursday, and all day on Friday to work on the midterm. The midterm covers everything that we've talked about in class so far, from the solids, liquids, gases, to the physical, chemical properties, to the protons, neutrons, electrons, even including the pure and mixture substances and the chemical bonding stuff that we'll talk about on Thursday. That all could potentially be covered on the midterm. The good news for you guys, besides the fact that you have 3 days to work on it, is that it is an open note midterm. So you have the entire Google Classroom to go back and look back through the notes in case you need help with the question on the midterm. So all of that will be open to you while you're taking the midterm. Just like always, you have 2 different options for completing it. You can do the Google Doc version, which is set up just like you'd see on the paper midterm, or you could do the Google Form version. The Google Form one is a little bit different than some of the other Google Forms that you've done so far, because this is a lot longer than most daily assignments. I think it's about 20 to 25 questions. I've separated them out into segments on the Google Form, so you don't feel like you're constantly scrolling way down. So the way the segments work is you'll answer the questions in one segment, and then you'll hit next to go on to the next one, answer some questions, and then hit next to go on to the next one until you get to the very end where you hit the submit button, just like you would on the normal assignment. As you can see, the midterm has a mixture of questions on it. There are some short answer style questions. We'll use a phrase or a sentence to answer the question. There are some multiple choice style questions. There are some fill in the blank style questions. There are some matching style questions when you get a little bit later on. So a wide variety of different question types are going to be covered on the midterm. Again, it is a little bit longer than a normal homework assignment, which is why it's not due in one day. So please take your time, read the questions carefully, make sure you understand what they're asking. Again, you can always go back and look at the old notes while you're working on your midterm if you want to find something that you think might help. Also, if you get to a question and you're kind of stuck, you're not really sure how to answer it or what the answer should be, you can always reach out to me for help. Obviously, I cannot help you actually answer the question itself, but if you're just really confused by the wording or you need a little bit of clarification, please let me know and I will do my best to help you as much as I can. I don't want anybody to miss a question on the midterm just because you didn't fully understand it or you weren't really sure how you were supposed to answer it. So again, it is really important. The midterm makes up a big chunk of your grade, and the final at the end of the term also makes up a big chunk of your grade. And so please make sure to get them in. Again, you'll see it be posted tomorrow morning, so just in a couple hours here, it'll go up, but it's not due until the end of the day on Friday. So you have all day, Wednesday, Thursday, and Friday to work on the midterm and get it turned back in to me. So please take your time. Try not to rush through it or leave it all to the very last minute and cram it all in. None of the questions should be super difficult or super confusing or super out of nowhere. But again, you can always reach out to me and I'll try to do my best to help you understand the question if you do get a little bit stuck. All right, does anybody have any questions on the midterm and what it's going to be like?
No, sir.
How long is that going to be, the midterm?
The midterm, I forget exactly. I think it's like 20 to 25 questions, somewhere in there. Hold on, let me take a look really quick. There you go, 20 questions. So 20 questions long, a mix of free response, multiple choice, fill in the blank, fill in the diagram. All together in one midterm exam.
Cool, thank you. Doesn't look too bad.
Worries.
Yeah, it doesn't look too bad.
Nope, it's all stuff that you've seen before. It's all stuff that we have talked about extensively, and a lot of it I've pulled from similar type of questions to the homework that you guys have been doing. So if you've been keeping up with the notes and the assignments in this class, then you should have no problem at all answering the different types of questions. All right, anybody else? Any other questions on either the midterm or anything else that we've gone over tonight so far?